me just see. Yeah, so many windows open. Okay. Right. Let me share my screen. Okay, so today we want to start with Plutus, which is like the built-in native smart contract language on Cardano. I mean, the last week we spent talking about Marlow, which is very nice, I think, but it's sort of like layer 2. I mean, it's implemented on top of Plutus, basically as a particularly complex Plutus contract. So Plutus is the fundamental one. And also, I mean, we talked about Turing completeness and so on. So Plutus is basically Turing complete. So in principle, you can do everything in Plutus that you can do in any other programming language. And I say basically because obviously, I mean, all these things with Turing completeness and so on are always on idealized machine with infinite memory and infinite time and so on. Obviously, on a realistic machine or also on a blockchain, there are always resource limits. So Plutus contracts get a certain budget as for memory, how much memory they can consume, and also how many computational steps they can perform during validation. And so that's parameters of blockchain. So in the last 2 years, it has increased once or twice. So that's not set in stone, but there are limits. Because of course, these, as I explained last time when I explained the extended UTXO model, these validators have to be executed when transactions are validated. So on every Cardano node, these validators have to be executed. And obviously, I mean, it would be an attack vector on the blockchain if one could overload the Cardano nodes with giving them like computation that consume too much memory or last too long. So therefore, there are these limits. Right. So, okay, and what else should I say? I mean, actually now, I mean, especially now, I mean, Plutus somehow gets simpler and simpler over the years. So it's far less painful to work with it than it was 2 years ago. And the tooling also gets better and better. So it's more and more fun, actually, and easier to work with it. Nevertheless, it's still sort of tricky to set everything up. And what I have done now, I mean, I have this Docker container, but I think it's not final. So the one we will give you that we will put in the repo will still be better. So I just cobbled something together so that I can do the lecture today. And I mean, it has a lot of moving parts. So I have this Cabal project file here. And so, I mean, must be careful that all the versions fit together because you need, I mean, Plutus and Cardano Node and all sorts of libraries. It has become better. I mean, we have talked, when we talked about Haskell, we have often talked about libraries on Hackage. And actually, it's possible to basically have something like Hackage, I mean, to have your own library repository. And IOG has actually done that, created something called Cardano Haskell packages. And that was a big improvement because as on Hackage, I mean, if you import it's relatively easy, as we have seen during the lecture on Haskell, to use libraries from Hackage because they work together with their dependencies. So it's relatively easy to get dependencies working together if you use things from Hackage. In the old days with Plutus, I mean, Plutus is on Hackage. So one had to use the IOG GitHub repos, or still has to use them, but it was always tricky to get the versions match up. But now there's this Cardano Haskell package, or CHEP, I think people abbreviate it, with consistent versions. So that's easier then. And here in this Cabal project file, this is what you have to do to basically import like a custom package. So it still uses the normal package for other dependencies, but it uses this custom repository of libraries for the IOG specific packages. And yeah, so there's lots of stuff here. That's the right. And what else? So that's for the Haskell dependencies. And yeah, so it's always a bit tricky to get it working. But these days, I mean, with Docker, or there's also this Demeter run that we tried to, or yeah, that we tried to use last time. Robertino and Karina tried to use it for Malo. I mean, it was a bad example because it didn't work, but normally that's also quite good. So normally there you have a browser environment where you don't have to install anything and can just start working, and you have all the Cardano dependencies in place already. Okay, and so let's start with our first example of Plutus, and maybe I should hide this stuff here first. So as I explained last time, extended UTXO model. So we have, I mean, before the extended part, an output on the blockchain just had an address and a value. And the extension means that the address can now be the hash of a script. And there's an additional datum. I said it's just an arbitrary piece of data. And when a transaction tries to consume such an output, use it as input for a transaction, then this script is executed. And as input, it gets the datum, the redeemer, which comes from the transaction that wants to spend it, and the context, which is basically information about the transaction that's currently being validated. And then the script can say yes or no. And then if it says yes, then it's okay to spend that input. Let's try to write such a script. Okay, and of course, I mean, this is about Plutus, so the programming language that these scripts are written in on the Cardano blockchain is called Plutus, or Plutus Core, or Plutus Script. And that is, you can think of it like a primitive version of Haskell. So it's, I mean, like Haskell without any syntactic sugar. However, nobody, to my knowledge, writes Plutus Core directly. So the standard way, or the official way to write Plutus, is to just write Haskell. And then there is a compiler plugin into GHC that compiles this Haskell to Plutus. So we'll see how to do that today. However, in the last year or so, there are now also alternatives. So other companies or other projects have created their own languages that compile to Plutus Core. So in particular, there's Aiken and Plutarch. I mean, Plutarch is actually, again, a different story, but in particular, there's Aiken. So that's more like Python-like or Rust-like. Yeah, and I think there's also PyCardano that's more Python-like, and then there's Aiken, which is more Rust-like. But anyway, so it's basically languages that are maybe more familiar for people that don't know Haskell, and that also compile to Plutus Core. But in somehow you must get to this Plutus Core. And once you have that, then you can basically create outputs at script addresses, and then also transactions that consume them. Okay, and maybe the first thing we should talk about is, I mean, I said datum and redeemer are arbitrary data. And that was, of course, a bit vague. And actually, that what, I mean, precisely the meaning is this built-in data type. So let's maybe look at that first.
Okay, could you zoom in a bit?
Yes. And before I zoom, yeah, okay. And one other thing I should mention, I mean, I mentioned it's tricky to get the environment right, but we will help you with that with like Docker containers and so on, or you can use Demeter. Another tricky thing is that I mean, maybe I should talk about that when I talk about compilation, but just as a, sorry, where am I? Here, just as a warning or as a glimpse. I mean, normally in our examples, we mostly for GHG options, we only use this all warnings. But you see here, there's a lot of other stuff that basically makes this compiler plugin work, but it also has disadvantages. So for example, the REPL is not as convenient as it normally is. So it's a bit, I mean, the tooling doesn't work as nicely as it normally works for Haskell. And therefore, I have now split my repository. I mean, I have this on-chain Cabal project. So the idea is that one should basically do as little as possible with these restricted options because it makes the Haskell part a bit painful. And then everything else you want to write in Haskell that's directly related to creating Plutus script or Plutus code should probably be in another repository where you have like use normal Haskell and then you have normal convenience. But probably we will run into that anyway soon. Okay, so let's first talk about, let me just open my REPL. And it's really good, it compiles. And there are, I mean, that also used to be more complicated, but these days, in principle, the most important packages you need is Plutus Ledger API and for all the data types. So of course we want to, I mean, in our scripts, we want to talk about blockchain specific things like addresses, public keys, values, I mean, ADA values and token values, all these types. So this is defined in here. And then the actual compilation stuff is in here, in Plutus TX. And then in this plugin, you never like need anything from that like directly. This is just to make this compilation work. So, but we'll see how that works soon. Okay, let me import this. Okay, and if I now go, sorry, let me just move this out of the way. Okay, and let me import this Plutus TX. Ask for information on built-in data. Okay, we see this is just a wrapper, basically. I mean, it's not a new type wrapper, but it's like a new type wrapper around something called data. So let's ask for data. Okay, and this is what I mean by arbitrary data. And if you look at it, I think it's very similar to JSON, for example. So what is data? So it can be, I mean, there are 1, 2, 3, 4, 5 constructors. So it can be an integer, so a number. It can be a byte string. It can be recursively a list of data. So that's like a JSON array, basically. It can be a list of key value pairs. So that's like a JSON object, but it's a bit more general than JSON objects. I think in JSON objects, the keys have to be strings. Not sure, but anyway, here so basically this is like the key and this is the value. And finally, this is like non-JSON like. This is more for algebraic data types. So it can be an integer and then a list of data. So this is like a constructor of an algebraic data type. For example, in lists, it would be near and cons. So the integer is basically the which constructor, the index of the constructor, and then the list of arguments. And you can, I mean, it's of course not the same as JSON, but you probably can see that it's very similar to JSON. And as you know, JSON can be used to serialize just about anything that can be serialized. So I always think of this data type like that. So it's basically a form, I mean, something that almost every data structure could be expressed in this type. And this so this is data, and built-in data is just a wrapper around it. So I mean, built-in data is just the built-in data constructor and then data. So, I mean, it behaves like this. Okay. And when I said that a smart contract on Cardano is basically a script or a function that takes datum, redeemer, and the context, the transaction itself, to decide whether it's okay to spend this output in this transaction. Then what that boils down to in Haskell is, so if you have a validator, it's in principle, it would be a function taking datum, taking a redeemer, taking the context, the transaction, and saying yes or no. So that's what one would expect. So actually, it's like on lowest level, all these three arguments are expressed as built-in data. So, I mean, the meaning is, so the first argument represents the datum, second argument represents the redeemer, the third argument represents the context, but all three are of the Haskell type built-in data. And we'll talk about how the encoding works soon. And also, instead of bool, what one would expect, it actually takes unit as a result type, which is strange. I mean, if you paid attention, I mean, in Haskell, when we talk about, I mean, if a Haskell function like that is weird, because we know unit only has one value. So no matter what the arguments are, there's only one possible return value, namely unit. So somehow a function like that doesn't make much sense in Haskell. But of course, Haskell also has error. So we always have this undefined or error or like infinite loop. So basically when the function doesn't have a result. And this is how Plutus works. So if it's okay, if the validation succeeds, then this function should return unit. And if it's not okay, if it doesn't succeed, if there should be a validation error, then one must produce an error in this function. So that's a bit un-Haskell. I mean, normally, I mean, it's a bit against this functional spirit, but that's the way how it works in Plutus. And at that point, I should also mention that even though Plutus is very similar to Haskell, one crucial or important difference is that Plutus is strict. It's not lazy. So, I mean, we've seen that Haskell uses laziness, which, I mean, makes it, I mean, it's quite unique in some, and allows some interesting things that you can't do in other languages, but Plutus itself is strict. Okay, so that's the signature of a validator. And so now let's implement one. And let me call it a gift validator. So it takes a datum and a redeemer and the context, and now should either throw an exception or create an error if validation is not okay, or result in unit if it is okay. So the simplest thing that we can possibly write is not look at any of the three arguments and always return unit. And that means that it's always okay. I mean, remember, what does this validator do? So whenever somebody tries to consume an output setting the address given by this validator, then this validator is executed in the correct context. So with the datum, with the redeemer, and with the transaction that tries to spend it. And then if this function returns unit, then it's okay to spend this. And if it creates an error, then it's not okay to spend it. So this one never creates an error. So it's always okay to spend it. So this smart contract would say, no matter who tries to spend me, it's always okay. That's why I call it gift, because if you send money to this address, the address given by this validator, anybody can spend that. So whoever comes first can grab that. So that's yeah, go ahead.
We have a question.
Yes.
What is the reason behind Plutus being strict in evaluation?
It's a good question, and I honestly don't really know. I mean, could be that it's easier to implement the compiler or maybe it's to make it more predictable. I mean, one problem with Haskell is, or one problem with laziness is it makes it difficult to predict performance. So it's sometimes quite hard to see, like, estimate runtime or memory consumption of a Haskell program, because you really have to understand which parts will be evaluated and which won't. And that can make it quite tricky to reason about the resource requirements of a Haskell program. And that's much easier in a strict language. So that might be the reason that they wanted to make it predictable how much resources the scripts consume. But I'm not sure. So maybe we should ask the Plutus team. It's a good question. I've asked myself that as well. I assume it has something to do with predictability, but I'm not 100% sure. Right, other questions?
No, thanks. It says that.
Okay. Okay, so that's that. But I mean, this is of course just a Haskell function, plain Haskell. I mean, it's nothing to do with Plutus except that it uses this Plutus type built-in data. So now the question is, how do we actually compile that to Plutus? And this has recently changed, so it's easier now than it used to be. So in this Plutus TX model, there's a function called compile. Okay, so it's a bit terrifying. Maybe I should import this thcompat. I'm not sure. I'm not sure whether I can import that. Let me try. I mean, it looks a bit intimidating. Just see if I can import this. Oh no, made a mistake. Did I didn't want to rebuild the container. No, that's bad.
No, but it's okay. But likely you have to like do it twice because it detects that it's already running, and you have to like
Okay.
code. Yeah.
I just hope that I don't have to build everything now. I
No.
rebuilt it. But okay. Of course. No, I think that was a very bad thing that I just did. Because now it has to rebuild everything, and that's like takes forever. That is something, Robertino, maybe you also think about whether it's possible to put that into the container, that it builds all these heavy lifting things like Plutus TX somehow in the container already.
Yes. I will try to like pre-compile all the binaries and upload just a finished match.
Yeah, but the problem was normally when I press Control Alt P, then I reload the window. But now, because I was doctoring with this container thing, now I instead did rebuild container, and that is now painful because now I think if I do cabal build, it will take forever because it's and now build all these things again. This is another pain point. I mean, even if you set up the environment right, it can take an hour or so to build everything. I hope it will be fast on my side now. Yeah, it doesn't look too bad, but I mean, look what all I have to build now. All these Haskell packages.
Yeah. Maybe better to just remove thcompat and or not.
No, I think that doesn't help. I mean, because I rebuilt the container, somehow it always wipes out this. So each time I changed the container, I had to rebuild everything afterwards.
Okay, that's
So
also that's also a thing we can solve. We can put a volume that contains everything built. So even if you like a different container.
Right. So I wanted to, I mean, so now while I wait for this to build, oh, there it is. I can just instead just look online. So if I go to stakes, I make bigger in a second. So let's talk about that then. Hopefully right. Just a bit bigger. So there's this Plutus TX on GitHub, and I suppose it's in code, I hope. Right. And the Plutus, not sure where compile is. Obviously not there.
You can use the search on top to search inside the repo.
In GitHub as well? Ah, okay.
Yes, at the top.
Not that one.
That one.
Maybe there. I think that's not it. It's probably in some th. Ugh. Irritating. I hope this doesn't take too long, but it normally takes a while. I mean, normally let's see. Sorry. It looks promising. Yeah, that's what I was that I had before. But anyway, here we can look at this data again. So it's a bit nicer. And so we talk about all of that soon. But the compile is not there, but now I can. Okay, yes, there. Right. Okay. So first of all, compiled code. So this is basically that represents Plutus core. So the code we want to generate. And the type parameter A is basically the Haskell type it corresponds to. You can think of this as a Plutus program, I mean, like a Haskell program of type A or a Haskell value of type A that has been compiled to Plutus. And as you see here, this compile function that we will use for this purpose to compile, it uses a splice queue type, which comes from template Haskell. So it's not just, I mean, it's of course, I mean, template Haskell is also Haskell, but one actually needs template Haskell to do this. So let me just, while this is compiling, so hopefully it won't take forever. So the idea is we basically to get the actual validator. I mean, this is actually, I should call that make gift validator or something. So this is a normal Haskell function. But what we actually want is Plutus. So we want something of type compiled code, built-in data to built-in data to built-in data to unit. So we want to, I mean, take something with this signature in Haskell and compile it to Plutus. And we can do that using this compile function and template Haskell we used last time. And let me just glimpse that I don't get that wrong. Right, so we use this splice, the typed splice we talked about last time. Remember, there were two types of template Haskell, two flavors, the typed version and the untyped version, and the $$ was for the typed version. That's how you splice template Haskell piece in. So just check here. Okay. Right, I mean, I can just copy paste that. Sorry. Okay, make gift validator. Right. So, and if we look at the GitHub page again here, the documentation. So the input to that function is not the Haskell itself, not the A, but basically a code of that. So in this Q monad. So that's why we use the Oxford brackets here. So we basically take the code, the Haskell code represented as code, so not the value of this, not the function itself, but the code of this function. We get it by putting it into Oxford brackets, as we discussed in the lecture on template Haskell. And then we give that to the compile function. And then we splice the result back into our Haskell file. So this is the template Haskell, or almost all template Haskell you need in order to work with Plutus. There's one more thing, this one. So for this to work properly, I mean, normally, I mean, template Haskell is a little bit fragile, and this whole mechanism is a little bit brittle. So in the old days, like in the first versions of Plutus, you basically had to write your Haskell code inside these Oxford brackets. But if you, I mean, that's normally not nice. I mean, you want to write it like in a separate function and maybe use helper function and so on. And to make all of that more reliable, one can use this pragma, this inlineable pragma, which means that here where this word make gift validator stands, the compiler will inline the definition. So this is then the same as instead of make gift validator here, I would have like written the actual code inside the brackets. And that's what needed for this mechanism with the plugin and to properly compile it to Plutus. So normally everything you want to use in the compile as an argument to compile needs this inlineable pragma attached to it. Right, let me see how far we are. So still going on. Right. Okay, maybe in the meantime, so there are other things we can do in the meantime or talk about. Because, okay, fine. So now, I mean, provided that this now works and compiles, then we have our validator. So now, of course, the question is what to do about it. I mean, how to work with it. And there are two sides to that. Or let me say that this is what normally call off-chain code. So this here is on-chain code. So the actual smart contracts are called on-chain code. But then there's also the other side of the coin, the so-called off-chain code, and that is how to actually use it. So off-chain code has like two parts. I mean, off-chain code is interaction with the blockchain, and that has two parts. You want to get information from the blockchain, like see, I mean, find out about the UTXOs at a given address, their values, their data, and so on. And of course, you also want to submit transactions. So you want to construct transactions and you want to submit transactions. So it's querying on the one side, getting information, and like affecting action. I mean, acting and submitting actual transactions. So, I mean, typically, like a DApp or anything to do with Plutus always has these phases. I mean, you look at the situation, so you query the blockchain. That depends, of course, on what you try to do, what you're interested in. I mean, typically, you look at certain addresses to see who has how much, whatever. Then you decide what to do. You construct one or more transactions, and then you submit those transactions. And then it repeats. I mean, you check again on the blockchain what's the situation. You create transactions and you submit them. And there are various ways to do this off-chain part. And on Thursday, when the second part of Malo, we use this Malo runtime CLI to do this in the case of Malo, to interact with the blockchain. But that, of course, is specialized specifically for Malo. So for Plutus, there is like the low-level version that we will also start with, Cardano CLI, that we also used a bit on Thursday. So that has nothing to do with Marlowe. It's basically for Cardano in general to interact with the blockchain. And then there are also options to, I mean, Cardano CLI is like a command line tool, so it's more or less manual or bash. But then there are also various ways to do it from inside a programming language. I also mentioned that last time already. So there is, for example, Lucid that we will look at maybe on Thursday to do from TypeScript. But of course, I mean, this is a Haskell course primarily. So there's also an option to do it from Haskell with the open source library called Atlas Cardano. There was also an IOG in-house solution, but that was sort of a disaster and nobody used it, and it's not developed anymore, not supported, I think, or at least only a few parts of it. So the idea is that today we first do it with the Cardano CLI and then maybe in the last hour or so with Atlas to see how to do these things from Haskell. Okay, but in any case, no matter what you do, I mean, there are two parts to this off-chain code. I mean, at least in this specific example, this gift validator. So somebody has to make a gift and then somebody has to collect a gift. So making gift in this case means somebody has to create a UTXO at the script address, send some money there. And then once it's there, then somebody else can create a transaction. So that's one transaction to actually produce an output. And then there must be another can be another transaction that consumes an output. And I have mentioned that, but maybe I haven't stressed it or emphasized it enough. Validation in the EUTXO model only happens when you try to spend something, when you try to consume an output sitting at a smart contract address, not when you send something there. So everybody can always send anything anywhere in Cardano. So anybody can send whatever to any script address. No validation is run, no script is executed. So the validation scripts are only executed if you try to spend something from a smart contract address. Nevertheless, if we want to make this gift, so we want to create an UTXO at this address, then first of all, we need to get our hands on the address. So we must know which address that is. And we also need to create a datum. And in this case, because the validator completely ignores the datum, but nevertheless, we need to use some datum. Because one thing with Plutus is it always expects a datum. Datums in Cardano are optional. So an output can have a datum, but it doesn't need to have a datum. But if you have output at a Plutus script address without a datum, it's unspendable. So if you send something to a Plutus script address without datum, then no matter what the validator says, that's forever lost, the value there. So the validator only basically executes if there is a datum. Of course, then it can still fail depending on what the validation logic says. But if there's no if there is no datum, then it doesn't matter what the validation logic says. It doesn't even run. The money is just lost. In order to send something there, we basically must find out the script address and we must have some datum that we can use. It can be anything of type built-in data, but we need something. And if we do it from the Cardano CLI, then this is normally represented in JSON format. So there's a way to serialize and deserialize built-in data to and from JSON. And the Cardano CLI, when you want to specify a datum or redeemer, you use this, or you can use this JSON format. Right. So now I see we get, so I mean, there was all sorts of stuff that has nothing to do with Plutus, but now it's building Plutus TX. So we are getting close, I hope. Oh yeah, maybe while we are waiting for this, I can, because if we want to try out, I mean, we need some test money and we need an address to work with. So maybe I can try with that. Let me just, and I can't do that in the container because at the moment we don't have a Cardano node in the container. So let's just make this much bigger. Okay, so I have a Cardano CLI installed on my machine. And so let's start by setting up basically generate a test public private key pair that we can use. Let me just make directory keys. Okay, and as I said last time, the help system is normally quite good with these Cardano command line tools. If I Cardano CLI, I mean, one would think it should be the key command, but it's not. It's the address command. I ask for help there. Then I see there's the key gen subcommand. Key gen. And okay. And I think this is all optional. I must just specify two files, one file for the public key, the verification key, one file for the signing key. So let's do this. So verification key file, keys, whatever, user one or user vk, then signing key file, keys, user s key. That should hopefully work. Right, and now I can like look at the public one. So this is also a JSON format, but like it's called text envelope format. So a lot of things in the Cardano world can be serialized in this or written to a file in this text envelope format. It normally has like a type. In this case, it says it's a verification key, Shelley era of Cardano, blah, 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 then a human readable description, and then the actual key in binary or CBOR hex format. And the secret key would look similar. Right, so now I have that. I would also like my edges. So let's see what else we can do with the Cardano CLI. There's this build command, build a Shelley payment address. We could use delegation, but we don't. Let's keep things simple. Build. Okay. Now I can specify the payment verification key file. The only irritating thing about the Cardano CLI is that the names of the parameters are so long. I mean, it's nice, it's easier to understand, but it's a pain to type. There's also a way to set up auto completion, but I'm normally too lazy to do that, but I probably should. Okay, that's that. Then stake we don't use. Then we must specify with which network, so mainnet or testnet. And I want to use the gprod testnet, and that happens to have the testnet magic 1. So that's the same one we used last time for Malo. And out file, say keys user gprod address. Okay. So there I have an address. Now I can use some, I mean, I could, for example, maybe I should show you because I haven't last time. There is a faucet, so-called faucet. If I Google testnet faucet Cardano, then That's a way, basically, if you want to try something out on one of the Cardano testnet, then you can go to this faucet and ask for test money. I mean, obviously for the mainnet, there is no faucet, then everybody could just get money. But for the testnet, this is one way for you to get your hand on some test ADA. So you must just choose which testnet. So I said pre-prod. And yes, I want to receive test ADA, and you just paste an address there. I don't have an API key. If you have one, you can request more. If you do it like this, then I think you can only do this once every 24 hours for a specific address, or for a specific URL, actually, or IP. Okay, so now it should be there. So now how do I check how much money I have? Well, there's also Cardano CLI to the rescue. I mean, we used that last time in the Malo lecture as well. So there is query address. And you can do things like, for example, okay, address was obviously not okay. Oh, UTXO. I want UTXO. Sorry. UTXO. Right now, of course, in order to query the blockchain, I need a way to actually access the blockchain. And so we need access to a node. So we will set something up in the container as well of the repo, probably to the preview testnet, because that's easier, because that's smaller. Then you don't have to wait so long for the blockchain to sync. But as I said, I want to use the pre-prod, and I happen to have a node running. So I must just connect to it. And there are two ways I can give this parameter here, but I can also set an environment variable. And I think it's easier if I do this, because I will use that a lot. Node path. So that should be it, hopefully. Right. So now I have that. Now UTXO. So I have set so this is basically a Linux socket that gives me connection to a running Cardano node. Probably can ignore most of these. Can specify the address. That was my address that I just created. And then again, testnet magic. Or I can also do that with an environment. So probably I should, sorry. Because then I don't have to always type that everywhere. One. Okay, let's do this again. Address. I could optionally give an out file, but I don't have to. Now I hope my node works. Okay, right. So it worked. And now I see the faucet worked. And normally it gives you 10,000 test ADA. So and as I said last time, one ADA is 1,000,000 Loveless. Loveless is the smaller unit. So yes, so I got 10,000 test ADA now at this address. And here in this like text graphics, we also see the UTXO. So this is the hash of the transaction that the faucet used to send me these 10,000 ADA, and it was the output 0. So we could also now go to Cardano. I mean, if we want, we could go to Cardano scan that we also used last time, or another blockchain explorer. I normally use this. I must just switch to the right test net. So we want prod. And I can paste in the transaction hash. And there we see it sent 10,000 ADA to this address. So this is my address that I just created. Okay, so now I have the test ADA. Was something else I wanted to say? Not sure. Anyway, so okay, so by now hopefully it's still building, but should almost be done. Okay, so now I have the test Ada. So now in principle I can do this. Maybe we can see. So that's the transaction command. And there are sorts of things you can do with transactions. And there are like build raw and build are to actually create transactions. Build raw is more low level and build is more high level. But some things you cannot do with build. Actually, I forgot whether what I want to do I can do with build, but I'll start with build. Worst case I can switch. So, and for these things, it's always better to, I mean, I find to have a file and not do it directly at the command line because it's easier to change afterwards. So let's see. But I mean, we can at least ask for the help of the build command. So there's like lots of stuff. But I normally just start small and then, so for example, you specify an input like this. So you use tx in and then give the UTX like I explained last time in the format transaction hash and index. So in our case, and I mean, we want to make a gift. So that gift must come from somewhere. So that must come from these 10,000 ADA that I just got. Plus, of course, we must pay for transaction fees. So I do this again. So as input, we need to use this UTXO. So I mean, I can start with TX in, and now I would need to specify this UTXO hash this index. So now I've said I want to build a transaction that uses this UTXO as input. I could also create more I mean, I could use more inputs. So I can use this TX in argument several times. But let's see, I mean, now I want to create an output at the script address. And for that, I mean, I need the address, for example. So an output is normally specified with minus minus tx out, address and value. But I don't have the address yet. But of course, Cardano CLI to the rescue. I just, again, don't know where it is. I suppose at address. Probably again build. And earlier I used the add build command. Right, earlier I used this given my verification key to build my address. But you can also use that for script addresses. So I use this payment verification key file argument, but you can also use a payment script file argument. So if we have the script, the Plutus script in a file, then we can use this command to get the actual address corresponding to the script. Let me see how far we are. Still not there, but I think now we're very close. Let's see. No, the history is too short to see. But I mean, it's already Cardano related stuff.
We could go over the off-chain code or not yet.
Yes, but I mean, yeah. What off-chain? I mean, the script, you mean?
Yeah, the actual like CLI scripts, bash scripts.
Yes. This would be this one. Let's see. So I mean, I had prepared something. Okay, some things we have already. So let's see. Or maybe. .
Do
Right,
we have
so
it already compiled? Sorry for interrupting. Do you pre-compile it before?
oh yeah, I did. Yeah, no, I mean still from the Pioneer program, but maybe it's different now, the code, I'm not sure.
Right.
Oh, but I think we're almost there. But I should just create I mean I can already start. I mean, and this is like earlier, but this is quite sophisticated. I mean, I can just do this by hand now and start at least. So let me just delete this. Yeah, let me just be brave and delete it. Okay, so we want to do Cardano CLI transaction build. And as I said, so we have TX in. I think that's still my clipboard. So that was my UTXO. Now we have TX out. So now I must somehow find this address. We can do this later. Once this has compiled. But the format is what is the TX out address value. So now I can decide, I mean, what gift I want to make. And in the case of, I mean, for example, if I want to make the gift 100 ADA, so then it would be 100 million Loveless. And I think this should be in like this. Right. I think Cardano API is one of the last things that gets built.
Yes, I think so too. And like everyone, you don't have to wait for this. You will have this precompiled, so it's okay. Don't worry about it.
Yes, that's always painful. But the good news is, I mean, this is now was stupid of me that I rebuilt the container I shouldn't have. But I mean, normally when you work, I mean, this pain is like when you set up your project in the beginning, you have to build all these libraries. But then, of course, once they're built, Cabal caches them normally. So, I mean, then you just have to compile your own code. So normally it's not too bad. I mean, each time you like upgrade the versions or so, you have to wait a while to compile. But normally, I mean, for several weeks or so, you don't upgrade the versions, and then you just, I mean, you never have to do that. I mean, it's not as you have to do this every day normally. It's just now, okay, looks promising. Okay, fine. What else can I say?
Oh,
I think it's done. Yes.
something. Yeah. Yes, it's compiling our stuff now.
Okay, good, great. Okay, yeah, this is now, I just get the errors because I had that here as well. Like cheating. Right. So now, I mean, we can. Okay, so sorry about that. But I mean, I didn't waste the time, I hope. Because I explained other stuff in the meantime. So I hope we're good. Right. So now we're in the REPL again, and I can import Plutus TX. Okay, fine. And now let me ask for information on compile. Now it looks indeed nicer. But I mean, in the meantime, we found it on the internet anyway. Right. And I mean, I have this gift validator now. I would have if it had a show instance. It obviously hasn't. Right, but now what to do with it? I mean, later today, hopefully in the last hour or so, when we use Atlas to work with Haskell, then that's all we need. I mean, we need this validator, the compiled code, and then we can proceed from that. But if we want to use the Cardano CLI, as we saw here, somewhere here, I need this in a file, this Plutus script in a file. And I created a helper function for that. So that's also something that is easier with Atlas. One additional pain point with Plutus is that there are like so many moving parts, and there are also like different libraries. I mean, there's the Cardano ledger stuff, basically the low-level blockchain mechanics. Then there's Cardano API, which is the Haskell library powering the Cardano CLI. And then there's Plutus. And those three things have been written by three different teams in IOG. And they all need like similar things, like, for example, addresses and public keys, but they all have different types for them. So you always have to like convert back and forth. So that's all a bit painful. And because of that, I created this helper utility here. And in particular, this one, serializable to script. So if we ask information in the REPL on compiled code, then we don't see anything useful. Just a second. Where's the serialize? In codec serialize. Just a second. Import codec serialize. We ask again. Why not? Okay. I don't know why I don't. I'm just confused why I don't see that compiled code is serializable. It's not. Okay, okay. There's something called. Okay, fine. Sorry. Right. There's something in Plutus v2 serialized compiled code. So as I said, these conversions are always a pain. That's why I created this utility module to make that easier. So we have compiled code now, and we want to serialize it to disk. And in order to do that, there's this helper function here, code to script, that takes compiled code and converts it into something that's called script, Plutus script. So this one comes from the Plutus library, and this is in the Cardano API, I think. Plutus script, yes, that comes from the Cardano API. Plutus script takes a parameter which version of Plutus it is. So at the moment we use Plutus version 2. So there was a Plutus version 1. Then it would be v1. So in order to get from Plutus to the Cardano API type, this Plutus script type, you can use the serialize compiled code function. And I think yeah, and then you can sorry, let me import. I don't know what this now does, the Plutus v2. Maybe we can just take it, serialize compiled code, and then serializable to a script. So anything that's serializable, we can convert to a script. Let me just use this serialize compiled code. Sorry. Serialize compiled code. Cardano or Plutus. That here as well. Obviously not. But shouldn't it be there as well? I want, sorry, Plutus ledger API. The problem is, I think this is an old version. Um,
Maybe if you change the URL to v2,
mhm,
Ledger API is still there. So
yeah. Okay. But this function serialized compile code somehow is not there. But it does exist, obviously, because this compiles. Where does it's supposed to come from? Plutus Ledger API v2. Let me Plutus Ledger API v2 serialize compiled code. Okay, fine. So that goes to serialized script. Okay. And now, okay, fine. Serialized script. And if we ask for information on serialized script, then we see it's basically just a type synonym for a byte string. So this serialized compiled code converts that into a byte string. And of course, I mean, in principle, we could just use this byte string, but we want it not just as a byte string, we want it in this text envelope format that I mentioned earlier. And once we have this, so this, okay, fine. So this converts it into the serialized script, short byte string. Then I don't know what serializable. Oh yeah, this is this. So once I have that, by calling serialize, I serialize it to byte string, then I convert it to a strict byte string, then to a short byte string, whatever that means. And then there's a in this Plutus Cardano API, there's Plutus script serialized. That's a new type wrapper around short byte strings. Then I have it in this format. And once I have it in that format, in the Cardano API, there is this write file text envelope, and scripts can be written. I mean, I said earlier, I showed you the public key I created that was could be written in this file text envelope form, and Plutus scripts can also be written to that. So I have this helper function here, write script to file. So I always find that annoying that, I mean, you always have to juggle like Cardano API, Plutus API, Plutus, Ledger, and then all sorts of various serialization libraries and byte string, and it's always very confusing. Therefore, it's good if you have like helper functions. So there's this utilities module that we will also share with you. But if you use something like Atlas Cardano, then there are also functions to do these things so that you don't have to worry about all of this. Anyway, so we can use from this utilities library, we can use this write code to file, and that should hopefully just work. So let's try this. So I just execute this. Okay, but probably I don't have an assets folder yet. So let's create one. I added it because I restructured this a bit. So there is an assets folder. I think I have stuff in the way. Sorry. There is this assets folder, but I shifted everything one level down. So it's just like this. Okay. Right. So now I have it in serialized form. So we look at it. There it is. So it's a very, I mean, it's a very short script, which is not surprising because it doesn't do anything. It ignores all its arguments and just returns unit. So this is basically the serialized form of this very first smart contract I wrote. Okay, and now I can proceed. So now I can use this Cardano CLI address build payment payment script file, and this is now assets. No, for assets give Plutus. Everything else should be fine. Let me just try it. Okay, there's our address. So this is now the address of the smart contract. And technically, it's basically this script, this script, basically this script, the bytes represent the actual script that is hashed, and then the hash is more or less the address. I mean, morally, it's the address. So the hash of the script. Right. So now we can go to this make gift thing. So now we have our address. So I can take that and paste it there. And if I do it like that, let's just see what happens. Let's do that from here. So where is that now? It's in scripts, make gift. So now it complains, of course. Okay, so it tells me I need more parameters. So I need to specify change address. So we explained that last time that, normally you don't have the exact amount that you need to spend in your input. Normally you need to more and then you need change. So this Cardano CLI build command allows you to specify an address where the change should go, and then it will automatically generate change output. So there we want to use our own address, of course. And that was, where did I put that? Keys, right. What did I call it? User preprod address. So this address. Okay. Change address. Okay. Let's try again. Now it complains. No, it doesn't complain. Ah. Oh yeah, sorry. Let's complain. I think now it will say that, okay. Ah. I think the format here is actually like this. Now, okay. I must give an out file. So where to put this? So let's say out file, make gift unsigned or something. Can't possibly take so long. I must have made a mistake. Oh no, it did take so long. Okay. Yeah, that even is. But I should do. Let me just run it again. I have no idea why that takes forever, but it needs to, it's not as easy as it looks, because in order to calculate the transaction fees, for example, it needs information from the blockchain about parameters. And so it must talk to the node actually. Okay, okay, so that would now be this, and this would be the transaction. However, as I said before, we need a datum. If we don't attach a datum to our output, the gift will be unspendable. And we can take arbitrary datum, but there must be some. And so now the question is, how do we do that, and how do we get how do put that into a JSON format. And again, this helper library that I created, there's this data to JSON. There is a type class that we will talk about a bit more soon, but to data, you can think of that as the ASON type class to JSON. I mean, I said this data type in Plutus is very similar to JSON. So similarly as there is a type class in the ASON library to serialize Haskell values to JSON, there's also a type class in the Plutus libraries called toData to serialize Haskell values to data, to a Plutus data. That's called toData. And most common types are an instance. And once you have that, you can actually convert it to JSON. So I have this data to JSON. I also have print data to JSON, so we can try this out. So let's try it out. Probably it's not imported. So let me go back here. Right. Data to file. And so I need just a file path and a Haskell value that can be serialized to data, and then it will write that to a file. So let's do this here. Save unit datum or save datum. Datum. So write data to file. Now this file, I can also put it in the assets folder. Let's call it unit datum. As I said, I can use an arbitrary Haskell value that can be serialized to data because the validator doesn't care. So I can just, I mean, I could use anything like a number 42 or whatever, but I can also use like unit because unit is serializable to datum. Let's do this. Okay, and this is what it looks like. I mean, we looked at the data type before. And so in this case, it uses this constructor. So constructor 0 and no arguments. Whatever, I mean, it could be anything. So now we have this. And if we look back at not the address build, but the transaction build command, then we use the tx out somewhere. Tx out and here. And now we see there's something with datum. And this is now, there are 3 ways in Cardano to attach datum to an output. And that's a bit unfortunate because in my opinion, there should be only the one, but that's also historical reasons. So one way is to don't attach the datum at all, only its hash. And then it's the spender's responsibility to attach actual datum. Second way is to attach the hash and include the actual datum in the transaction body. Then it's still the spender's responsibility to provide the actual datum, but at least the actual datum can be found on the blockchain. And then finally, there is the option to attach the actual datum to the output, not just its hash. And that's called inline datum. So we could use this, for example. Just a second. So I don't know what I should do. I mean, I personally prefer this inline version these days. So that's the newest one, the most modern one. But I think it's the most convenient one. So, I mean, we can, for example, use that. So it's this parameter. So if we go back to our script, sorry, it should go here. And now we can specify this, what was it? assets. That's probably in this folder 24. Hello world. Assets. You call it unit. What did I call it? Unit datum JSON. Yeah. Datum JSON. Okay. Let's try this again. Okay. It should have become a bit more expensive now. So now it's 166,000 Loveless. And before it was 165,000. Okay, so the difference is now because earlier we didn't have a datum attached. Now we attach a datum, so the transaction gets a little bit bigger, but not much. So I mean, we already. So I'm sure maybe I should make the gift and then we can have a break. So hopefully, so this should hopefully now be fine. So now we have this transaction, which is now a bit bigger than before. And again, just to briefly go over it, so we specify the change address that we get the change. We specify the input, in this case only one, and we only have one available anyway. Then we specify one or more outputs. So this is the script address, and we say we want to send 100 ADA to the script address. Then we attach the datum. I decided to use inline datum, so the datum itself is attached, and we specify it in the form of a JSON file. And then we say where the transaction should be written. So this is now an unsigned transaction. So now we have to sign it. So that's again Cardano CLI transaction. I think it's called sign. So we must tell it where to find the unsigned transaction. So tx body file was this make gift unsigned. Then where we want to write the signed transaction. What else? We need, now that we need to sign it, of course, we need the actual private key. So signing key file keys user S key, the secret key. Then mainnet testnet, I set the environment variable, so I don't have to do this. And oh no, sorry, this was wrong. This tx file, that's if we already, so I don't need that. I need the out file. That is if you already have a transaction to add another signature. But I don't have one yet, so it's only the unsigned one. So out file txs make gift tx. Okay, that just worked. So okay, so this is now the signed one, and we see here in the type, it's a witness. Witness is basically a synonym for signed. So it's witnessed by my secret key, this transaction. And now finally I want to submit it. So I think there's transaction submit. Yes. So there
yes.
I just need the
file.
The file tx file txs make gift tx, and hopefully that works. Yes. Wait. Now somehow it doesn't tell me the transaction hash. It's a bit annoying. Surely there is a way to get the transaction hash. I'm not sure whether the Cardano layer has that. Yes, it does. So there's a txid command. Okay, and it takes either the unsigned or the signed file. So we can, for example, use the tx file, txs, make gift tx. Okay, so this should be the transaction hash. And also note that this is, I mean, even if it's unsigned, the hash is already known before you even submit it. So that's completely deterministic. Because the hash of the transaction only depends on like things that are already known, independent on the situation on the blockchain. Just depends on the inputs and outputs and so on of the transaction itself. So now I can go to my didn't I have one open already? Yes. Now I can go back to the Explorer and paste in this hash. And now, yes, that should be the transaction we just did. So yeah, it sends 100 ADA, and this is now the script address. We can look at the details, the UTXOs. So we spent the one with the 10,000 ADA. That's our input, our only input, and we have two outputs. One, this is the one to the script address, to our gift contract, and this is our change. So our change is roughly 9,900. It's a bit less because of the transaction fees. And finally, we see here that, I mean, this is a script address, so a smart contract address. And this tells us that there is datum attached, datum hash, and also the datum itself, because we use inline datum. And we can even, if we go to inspect, then here's the like JSON decoded, which is again this what I saw earlier, what we saw earlier in the REPL. So that's the representation of the unit value in Haskell. Okay, so now we have this gift on the blockchain. So now, of course, it's a risk that somebody, if we have a break now, grabs it from us. But I hope that won't happen.
We could give that as a challenge.
Yes.
Yeah.
Okay, so I would suggest we have a break maybe until 50, and then we can try to grab that gift again.
Sure.
To show you. I mean, that's the interesting part, because until now, just to stress that again, no validation has happened yet. So no Plutus script has been executed, because when you put something somewhere at a script address, that the script is not executed. It's only executed when it checks whether you are allowed to spend. So right now we haven't tried to spend anything from this address. Okay, but we can do that after the break. So let's 50. Okay.
Okay.
Okay, thank you.
We are here, Lars.
I'm here as well. Just now.
Good. Okay, right. So now we made our gift. Now let's collect it or try to collect it. I mean, of course, as I said, somebody could already, of course, I mean, this is a public blockchain. So let's just see whether. I mean, right now, I hope it's still there. Yes.
Yes.
This. Okay. Anyway, right. So now collecting it. Let me just. So here, copy this. Was it 24? Scripts. Make gift to and for scripts. Select gift. Okay. Scripts collect gift. Okay, fine. So change address, we can use the same one because it's again us. I mean, I will just try to collect my own gift. Of course, if you now try to collect it, you would your address there. So now TX in, we must, I mean, we can, for example, look on Cardano scan. So there was, I mean, this one that we just looked at, and we can look at UTXOs. So this was the first output of this transaction. So the transaction hash was this. And it was the first output, so index 0. So that's the one we try to grab. And this is now, we don't have to specify any output, because if we don't, then automatically everything is changed. So we will get, I mean, everything that's not explicitly sent somewhere else will be converted into a changed output, and so to our own address. But if I did it like this, then it should complain that I didn't specify a datum or something. So let's just see what happens if I run this script. Nothing happens because, yes. Or maybe it doesn't complain, I don't know. But it should, because it can't evaluate the, I mean, it must know about the datum for whatever reason. No idea. But anyway, we should specify the datum. Maybe in this case, I don't know why that works, but it shouldn't, or at least normally it won't. So now we must see for TX in how we, normally, as I said, 3 ways. I mean, this needs repeating several times. So there are 3 ways to handle datum on Cardano. One is the person that creates the output only attaches the hash of the datum. And if you want to spend this output in the spending transaction, you have to specify the actual datum. And then the validation will check that the datum you claim is the datum hashes to the hash that's stored in the output. That's basically the cheapest version for the creator of the output, because it only has to include the hash. Then the second possibility is that the creator of the output specifies the hash, but also attaches the actual datum to the transaction. But in that case, still the spender of the transaction also has to include the datum while spending. The advantage is only that then in that case, the datum is actually on the blockchain and can be found on the blockchain. Otherwise, how does the spender of the transaction know which datum to use? And the most modern way that I would recommend in normal cases is to use this inline datum, which we did when we created it. So in that case, the datum is already attached to the output. And in that case, the spender doesn't need to repeat that, and I mean, normally if you could specify it like as a JSON file or whatever, but then you can use this TX inline datum present, which should say, okay, there is an inline datum on the blockchain, you can just use that. So I should actually use this. Right. And no. Why? What? No, something's wrong. Great. Oh, redeemer. Right. Okay, this was datum, but we also need a redeemer. So the datum is attached to the output, but when you try to spend from a script output, you also need a redeemer. The redeemer comes from the spender. It's like a generalized signature. In our case, the redeemer value is unimportant because it's ignored by the validator, but we need to specify one. And there are again TX in, blah, blah, blah. Here, TX in redeemer, and there are different options, but we can use JSON file, and we can use, because the value itself doesn't matter, we must just specify one. We can use the same file that we used for the datum, this unit datum thing. We could use an arbitrary other datum as well. So we can use, what was it? I mean, the path was, so this one here, we can copy that. Why is this happening to me? Okay. And as I said, this is just a coincidence now, and because this validator is so simple that I can use the same value for the redeemer that I also use for the datum. Okay, so this should now work, hopefully. Nope. Ah, right. I also need to specify the actual validator script, because I mean, there's not the actual script is not on the blockchain, only the address of the script. I mean, so the address I try to collect from is the script address, but that's only the hash of the script. But the spender must also provide the actual script. And there are also like several ways, but so let's see.
I think it's TX
TX
in
in
script
file.
file. Yeah.
Yes, this one. So I can use that one. And now where is my actual script? So that's also in assets. So it's 24 hello world assets. And what was it called? Gift Plutus, I think. Right. Okay. Okay, so it was obviously not called Gift Plutus. Right. That was, why is it now not finding this one? Of 25. For whatever reason, I wrote 25 instead of 24, it seems. Who knows why? Okay. So this seems to work. Okay. So
Yes.
this is
Actually great, because like every time you have an error, there's like another thing that you have to take into account. So it's really useful.
exactly, yes, exactly. Right, so collaterals. I mean, I said last time that one of the great things about Cardano in comparison to Ethereum is that you never, I mean, if a transaction fails, it fails, but you don't have to pay any gas fees or transaction fees because you already know it will, I mean, either you already know before you even send it that it fails, and the only thing that basically can happen between sending it and I mean after sending it is that somebody else spent a UTXO that you wanted to consume. But nevertheless, if you really want to shoot yourself in the foot, there is a way to force a transaction to be submitted, even though you know it will fail, that validation will fail. And the way it technically works in Cardano is there are two phases of validation. So one is cheap, and that does these things like checking whether all the inputs you want to consume are actually still present. So that's for free. So if that fails, you don't have to pay for it. But then there's the second phase of validation that actually runs all the smart contracts. And that's quite expensive for nodes to do. But as I said, but that you can check before you even submit it because you have all the information locally. It doesn't matter what happened on the blockchain. So you can do that locally. So you already know your smart contract would fail before you submit the transaction. So there you also normally don't have to pay. But it's a way to force the node to submit it, even though you know it will fail. And if that was for free, then you could force, I mean, you could attack the blockchain by creating an expensive smart contract and then submitting invalid transactions, and then all the nodes would be busy running this expensive smart contract. So therefore, you have to pay for that. I mean, again, normally you never have to because you will check locally and it will fail and you never will submit it. But if you, I mean, you can force it, and in that case, if it then fails, you would have to pay. But the problem is, how do you pay? I mean, how is the payment enforced? And that is where collateral comes in. So transactions that that use Plutus, so that try to spend from a Plutus smart contract, need to provide so collateral as an input. So right, and that must not be coming from a Plutus script. It must be from a pub key address that you control. And then if you do this thing of forcing the transaction through, even though it would fail, and it then indeed fails, then your collateral is forfeit, or at least part of it. So it's also, I mean, in the old version of Plutus, in the first version, it was the whole collateral input was gone, but now it's also possible to specify that only, I mean, it's only a certain amount, like 5 ADA or something, and you can specify that the change still gets back to you. But I anyway forgot. I mean, I need so I need to provide an input, a pub key input, and I can. So let me get this address at my address. So now there are these 9,900. So I must use this as an addition. I'm not sure these days. I haven't tried that yet. Whether I can just use that as a TX in and then all is good, or whether I explicitly need to.
You can use the same one. Yeah.
And do I have to explicitly specify collateral?
As far as
Yes.
I know, yes.
Yeah.
Yes.
Okay. Okay.
It can be
Right.
the same
In
UTX.
TX in collateral.
Okay. So I mean, I use this one as input, and I
Yeah,
can
and then
now, yes,
you-
TX in collateral.
yeah.
So like this,
Yes.
like that, for example. I'm not sure I need this TX in, because I mean, should be paid from the gift, the fees. So maybe I don't need that actually.
Yeah, I think it's not necessary.
Yeah. So
the
probably
gift,
like
the gift is
it's high enough to pay for the transaction fees, right?
yes, but the collateral has to be like
Yes,
your
the collateral has to be my own. Yes, but I don't need it as a regular input, right?
right. No.
Right. No. Yeah.
So this maybe this works now. Okay, that's strange. I've never seen that before.
The evaluation fails says
Too much space.
let me think. We already checked that, and it's not that big. It was a bit bigger, but not significantly, right? So
I mean, it's a tiny, it's as small a contract as can be. How can it?
yeah.
But it seems something is wrong with the serialization, but that's very strange. Annoying.
Input 0 is
Yeah, that's the one. I mean, I only have one input.
but you're in collateral. Okay. It's in collateral, yeah. And the 0 is the script one, right?
Yes.
Okay.
Let me just check whether. I mean, maybe someone did spend it in the meantime. No, but there's only one transaction still, so that's not it. What's that now? That's very strange. The script failed with Plutus script evaluation failed. Easily there's error. Too much space. Should have tried this out first.
Maybe we can change the order for the parameters sometimes.
Okay. Like this. I mean, I can also specify this as a normal input. I don't think that makes a difference, but
No, I think it's not a.
it can again be some incompatibility between formats, because I mean, now it should be actually the. Oh, that's strange now. Script for transaction input 0, because that's now not a script anymore.
Can you compare it
Or
with
in
pre-made script that we have? Oh,
uh
this one you wrote by hand right now, but there's another one. Like,
no, sorry. No, I'm the order. No, it's fine. It's
okay.
yeah, I know what you mean, but no, this I mean the order is here. They say in ascending order of TX IDs. So this one, the script one, is still the first one, even though in the script here I listed the other one earlier. So it seems the inputs are just sorted alphabetically, basically. So this is still the first input. Let me see. So I mean the inline datum should be perfectly fine, or maybe that must be before the order. Yeah, I mean, Karina, you're right. I mean, sometimes the order matters, but
Yeah, maybe we can try put the first the TX in, the old TX in,
yes.
TX in, and TX in script file, and then TX in inline datum present. And TX in redeemer file.
Like
And
this.
TX in, yeah, collateral. Yeah, and maybe chain address after. Yeah.
Let's try. You're right. Sometimes, I mean, the order is important somehow. I can also check in the documentation again. Just check here again. What do they say for TX in? Then TX in script file redeemer. So that's, I think, what we have. TX in script file. No, we have the.
Yeah,
I think the. No, that was right. First the datum, then the redeemer. But that was exactly as I had it. Right? It says TX in and then the datum and then the redeemer. I mean, first, sorry, TX in, then the script file, the datum, and redeemer. And that's exactly the order I have it. TX in, script file, datum, redeemer.
maybe the first TX in change for the second.
And but I don't really think that matters. That is very strange. Just Google that. I've never had that before, that error. So somehow I think it has probably is one of these annoying things again that Seaboard serialization has changed and I'm using incompatible versions. The Cardano CLI version I'm using. I mean, the one that I use to serialize the script is maybe a different one to the node version that I'm running. Although I thought it should all be in the newest one and the same one. Sounds like a Seaboard serialization issue somehow. That's very.
That error comes from the node, because I can't seem to find it in the repo.
It's probably
The-
from serialize or some Seaboard error, right?
Right, because I mean I cannot find it as a possible error in the node. It has the Cardano CLI inside in the actual node.
Right. I mean, if I Google this. Hmm. Maybe something, probably. Okay, maybe something is wrong with but I mean, this is now too late to fix, because I mean, the script is already on chain. So maybe this is just lost now. I mean, my guess would be that something is wrong with my utility function. I mean, that used to work like 6 months ago with this one that I'm using here to serialize the script, this one. But maybe something here is wrong now with this juggling of byte strings and so on. So that would be my guess. That I somehow created an invalid script. That in the meantime something has changed and you can't do it like this anymore. So maybe I should try with Atlas the whole thing. That hopefully works.
That will be, I mean, we wanted to show Atlas as well, but still, you could like do it with Atlas while we try to figure out what was the problem.
As in, you figure that out while I go on with Atlas.
Yes.
It's a bit weird, yeah. I mean, my guess would be that something is wrong with the serialization here. Probably this is wrong. Really know why or how, but annoying. Yeah, I don't really know what else. I mean, I've never had that error before, but I think, I mean, it sounds like, I mean, a Seaboard error and some incompatible. So as if the node is using different version of serialized than I'm using here. I don't know. Of course, it's not. I mean, there's also not much I can do. I mean, the Explorer. I mean, I don't know what happens. Can you check? I mean, this just says smart contract error, but you also don't see the Seaboard of the actual script. I mean, you can't. Because it's not there. I mean, it's just a hash of the script. Yeah, no idea what the best way forward is. I mean, I can hope that Atlas works. I mean, it can just also be that I have incompatible, but I mean, it should work actually. Okay, let me try to. I mean, it's a bit annoying, but yeah, maybe I should try to proceed with Atlas, and hopefully that works. And it's nicer anyway. Nobody does it should do it with Cardano CLI by hand anyway, and hopefully that works then. Okay. And then maybe you can figure something out, Robertino or Karina. Right, so sorry about that. I mean, right, so there's this open source Haskell library called Atlas Cardano, for doing this, what I did with the Cardano CLI now in Haskell. And hopefully that should work. I mean, everything will be compatible. So let me go to, I created this other project that I called off-chain, and there's nothing in it yet. So let me start by importing gift. And let me change into that directory. Cabal REPL. Hopefully that works. Okay, now I have to wait again until all sorts of stuff, but shouldn't be too bad, I hope. Let's just look at the right at the Cabal file. So here we don't have all these annoying GHG options. It's just like a normal Haskell project, and I'm importing the on-chain part, so where it defines validator, and also Atlas Cardano. Okay. Right. And if we look in Atlas Cardano, there is a folder called types, and all the relevant types for working with blockchain stuff are defined there, including script. And there we have something called GY validator. And there's this validator from Plutus, which takes something of the type we had just now, compiled code, built-in data, built-in data, built-in data unit. Let me just one more thing. Sorry. Yeah, so this here, and converts it into this GY validator. So let's do that first. Sorry. Where was I? Off-chain. And let me just import that qualified, because otherwise there are all sorts of name clashes. Okay. Okay, so now let's do gift validator. Type genius yields validator. Just check again. So this takes also a Plutus version as argument, like we saw earlier. Okay, now I have this validator from Plutus. Okay. And now be nice if this compiled, so I could actually use the REPL. Seems we still have to wait. Right, and now the same that I did before the break in the CLI to create this gift. Let's try to do this with Atlas now. And the way Atlas works is, I mean, you build your transactions like in a relatively abstract way, and that's mostly, everything is slow now on my machine because so that's in this TX builder. Common, I think, no class, sorry. It's in class. Right. The idea is that you first create something called a transaction bulletin, which specifies all the properties that your transaction should have. So let me also import that. TX builder. Right. Okay, and would be helpful if this compilation would be done, but unfortunately it's not. Right, and there's one other thing. Sorry, these this GYTX query monad and GYTX monad. So these are monads that are used to query the blockchain and to construct transactions. And I mean, the first thing I did with the Cardano CLI was create the address from the validator. So I can do that now as well. So that will be a field address. Let me just go back to types, address. So basically, this atlas has its own types for all the things you're interested in, like public keys and addresses and so on. And somewhere there will be a way to get an address from a validator. Just always forget what it's called. Here, address from validator. But for that, we also need a network. So it depends on whether we are on a test net or not. Just, sorry, one more thing. As soon as the compilation is done, I can also use the REPL. Then I don't have to browse on GitHub all the time. Right, and this first monad that's important is the one that can query the blockchain. And we see that in this monad, we can do things like find out our network ID, given a datum hash, looking up the datum. So I mentioned before the three ways how in Cardano can specify datums. Just attach the hash and the datum itself, or use inline datum. And so depending on which way you use, you need different. I mean, somebody that wants to actually spend an output there needs to somehow get its hand on the actual datum. So if it's inline datum, it's already there, so that's easy. But if the second method is used, that the hash is attached and the actual datum is in the transaction, then somehow you need to look up this datum by its datum hash. And the Cardano node can't do that. Even though the Cardano node in principle has the full history of the blockchain somewhere on disk, it can't do this. It doesn't maintain a database that tells you all the datums in the index by their datum hashes. For that, you need a tool called a chain indexer. And there are various ways to do that. I mean, various tools you can use. But this monad here abstracts away from that. So it just allows you to, given a hash in the monad, look up the datum. So that's one useful thing. And so here you can look up, for example, UTXO's at address, what we did with the Cardano CLI before. These things. We will talk about time later. Right. These things. It's all time related, so that will be a later lecture. Okay, and here's also script address. So we saw earlier in the type module that given a network and a validator, you can compute the address, but in this monad, you can do this with just a validator because the monad is aware of the network you're using. So this is probably what we should use, but then we must be in this monad. So if we are genius yield tx query, let's forget what it's called. Yes, query monad. Then we get the address, gift address. We can just use the script address gift validator. Okay, and now we can do the make gift. And let's say as a parameter, as argument for the function, we want to know how high the gift should be. So now we could also take native tokens into account if we want, or we could keep it simple and just restrict it to ADA. So, or loveless. So this is a value, so that can be ADA, it can be anything. That's my TX skeleton Plutus v2. Make gift. I think in this case, we don't just want to query, we want to construct a transaction. So we are in this monad, which has a bit more possibilities than one. Okay, V. And actually all we want of our transaction is that it must create an output of value V at the gift address. So in that case, we can say must have output. And now we must specify the output. And that's a record type with a variety of fields. And now it would really be nice if this was almost done, because then I get errors. But in the meantime, I can browse the code. So here we have outputs. And here's this record type. So we must specify those 4 things. So let's start with the address. Everything. Can you still hear me?
Yes. Lars? Can you hear?
Yes, Lars. Yes, Robertino.
Now we don't hear you, Lars. We lost you. Maybe it was too much for the computer.
No, maybe was the same problem that the last session. This computer maybe froze it.
Right. So should we wait or maybe take over?
Yeah, maybe.
Okay.
He
Re-entering the arena. Okay, guys, just anyone has any sort of question, something. I know this is like the basic fundamental stuff. Maybe if you already did the first lecture of the last Pluto Pioneer program, we already went through that. Still plenty of stuff changed since the last Plutus Pioneer program. Not plenty, but a few little things about the API itself changed, not conceptually, but the syntax. So actually this course will be, after we finish, will be the most updated one. So yeah, a couple of things change, but conceptually it's the same. But if anyone has any sort of questions while we wait for Lars to reconnect. Awesome, good. Thank you for the question, Jason. Just give me a sec. I'm going to share my screen and tell you about it. Okay, everyone can see my screen?
Yes.
Okay, amazing. So if we go to GHC's extension, let me zoom it a bit. We can search for, so that is an extension that makes it easy to write, to force strictness into a specific value or expression. So if we go to the manual, the user guide of the GHC's compiler, we can search for everything pretty much that can be done for the compiler. And in this case, we can search for the extension. Let me zoom in more, called bank patterns. So as you can see, this comes, the extension called bank patterns. It's included in GHC 2021. We usually, in Cardano, we usually use Haskell 2010, and then we activate the extensions one by one to make sure that we don't have more than we need. But GHC 2021 actually, right off the box, activates all these extensions. You might recognize a few of them because we use, for example, numeric underscores to make it easy, to make it more readable for numbers, explicit for all, derived font or derived foldable. So like the difference between all the different versions, quote unquote, of Haskell is that the original Haskell 98 has only these extensions out of the box. Then 2010 has on top of those all these ones, and 2021 all these ones. So in this specific case, the bank patterns one, you can add this little exclamation mark before an expression or a value, and you are telling the compiler, I want to make sure, I want to have this value, I need this value, even if your expression maybe doesn't try to use it elsewhere, or pretty much that's it. Because if your expression wants to use it, like out of like always, for example, one plus x, and then you print the value, y equals 1 plus x, and then you print the value. In that case, x needs to be evaluated to be printed. But if you don't print the value, there's no reason why GHC has to evaluate x. In this case, if you want to make sure that you want to evaluate x, you can just add this little, you have to first activate bank patterns, and then you add this little exclamation mark, And then it doesn't matter if you later use it or not, GHC will be forced to evaluate at least one level down that expression. Let me see if I can see the questions because I lost all of them. Okay, here. Chat. Yes, Kennedy, of course. So perfect. So you can find lots of, between the hackage in Google and the actual GHC users guide, you can find pretty much everything you're going to need ever. Let's see. If Lars doesn't connect, I might keep going with the lesson.
No, I'm back, but I didn't want to enter. And it's still compiling, and I think I crashed because, I mean, my machine was overloaded with the compilation, but I think it's almost done now.
Okay. Okay, I will leave you the screen.
Okay, thank you. So were there more questions?
Yes, there are other questions for.
Okay.
Kim said, is there a way to debug deploying the script without deploying to testnet?
That's a very good question. And I think the Plutus team was working on that, but I haven't seen, I mean, they wanted to write a debugger. I mean, if it's just, I mean, there are alternatives to testnet as well. I mean, first of all, you can set up your own blockchain. So maybe we also can demonstrate that in these 2 weeks that we want to talk about Plutus. So that's called a private testnet. So there's a relatively easy way to deploy your own blockchain just locally on your machine. So, and that has the advantage it's much faster than the public testnet. I mean, because you are in control of the parameters. So this private testnet that we are using has like it's like 100 times faster than the normal blockchain. So that's one option. And there's also, I think Robertino will talk about testing one of these lectures. And so there's something called Plutus Simple Model. That's like a unit testing library for Plutus. And that is also able to execute scripts. So there you don't even need any blockchain, not even like a private testnet. So you can do like run scripts so locally. But whether there's like a nice debugger where you can step through Plutus, I'm not sure. I think the Plutus team was working on that, but I haven't seen it yet.
Yeah, me neither.
Are there are there other questions?
Oh, sorry.
No, I think.
Okay, then okay, fine. Right now, so now my it has compiled everything, so I can hopefully go back. Right. Let me just off chain. Why it's not happening? Just a second. Off chain. Right. So now hopefully, never mind this extension. Okay. Okay, now I'm at least my editor is working again and I get proper error messages and so on. Okay, I'm not sure when I was cut off, but so we can just use the validator that we defined earlier and convert it to like the types that Atlas understands with this validator Plutus. So now we have a validator. And then using this query monad, because the query monad is aware of, I mean, it's basically a reader monad or state monad, reader monad that has some context information, including the network we are on. So it can, given the validator, give us the address. in that monad. And now I want to build this transaction skeleton. And all we need, I mean, all we want when we make the gift is we want this one output at the script address. So everything else is taken care of by Atlas, like the changes and so on. So we just have to say we want this one output. And now I get error because this GYTX out type that specifies an output has a couple of fields and they all have to be specified. So first the address, so GYTX address, and that, I mean, we can get here, but in the monad. So I may try to make life too easy for myself. So I need to first compute the address. Let's say address, gift address. Now I can use that here. So what's next? We need to specify the datum. It's a maybe value. So as I said, I mean, on Cardano, datums are optional, but for scripts, we always have to specify one. So I must use just out datum just, and now I need this GY datum type. So let's do Cabal REPL and import initial types. And I think there's something datum from Plutus data, which just takes something that can be converted to data that we saw before, and then an arbitrary Haskell value that can be converted to data, and that will give me a datum. So I can use that, just datum from Plutus data unit. So now what else do I need? The value. TX out value. That's just an argument here to my function. So I called it V. And then there's something called ref scripts. So we can talk about that later, but that's optional anyway, so I don't need this. Oh, why is it still complaining? Oh yeah, okay, fine. Okay. It's not monadic. So like this. Why is it complaining now? I think today is not my day. Okay, this is correct. Oh yeah, not gift address. I called it address. Right. Why is this complaining? Because I must also specify whether in which form. I mean, these three ways. So that can all be specified here. So it's not just the datum. I must also say whether I want to use inline datum. So that's basically like a Boolean. You can think of this like a Boolean. So we can ask for information on that. Out use inline datum. So I can either say use inline datum or don't use inline datum. So let's use it as before. Datum from Plutus data unit. Export use inline datum. Okay. Right, that should be it. So that like abstractly constructs this transaction. But now to actually construct it and transmit it and submit it, I of course need like a connection to a node or some way to interact with the blockchain, like a real world way. The way Atlas does that, there are different options. I mean, when I tried to do it on the Cardano CLI, I did it locally with a local node I'm running. Atlas provides different ways to do this. because I mean, you can run your local node, but as I mentioned before, a local node itself is not enough. If you want to look up datum values that somebody has provided just via its hash, you need something called a chain indexer. So you can have like a bunch of tools running locally. So Atlas supports that, but Atlas also supports third-party providers where you don't have to run anything locally. So there are at least, two that Atlas supports. One is called Blockfrost, one is called Maestro. So those are, you can just Google that. So for example, Blockfrost Cardano. So that's basically a service provider, a third-party service provider that you can communicate to via REST API, and it allows you basically full access to the Cardano blockchain. So you can query the blockchain, query UTXO's addresses and so on, look up datums, and also submit transactions. And then there's Maestro, which is similar. So they are competitors. And Atlas supports both, and both have like a free tier. So you can register and then you can get an API key, and both also have a Haskell API. So you don't have to like by hand construct REST API calls to these providers. So that's all integrated in Haskell, but Atlas integrates that as well. So you don't have to worry about that. You just specify which provider you want, Blockfrost or Maestro or local node, and then it just does that for you. And so, but you need to, so let's try this, make gift IO. So genius yield value IO, let's say transaction ID, make gift. So this basically corresponds to what I did earlier in the Cardano CLI, this transaction build. So this will build a transaction more or less, but it won't sign it and it won't submit it. So we still need that part. And for that, we need like a connection to a real blockchain. So so first we must configure our provider, whether we are using Blockfrost or Maestro. And there Atlas provides, has this genius yield config module. And there is, I hope, right. So we can specify that as JSON, and then there's this core config IO, given the file, where to find the config, IO genius yield core config. And once we have the core config, then that can be used to construct providers. And then you don't have to worry about whether you use Maestro or Blockfrost or whatever. So let's just explicitly give the file path. So that's config file. So first let's use this core config IO config file. So now we have the configuration. And just as an example, what that looks like, it looks like this. So it has this core provider where you specify what provider to use. And in my case, I will use Maestro. So I have now replaced my token here. But as I said, you can get one for free. And you specify the network. So in our case, that's gprod. And then it also supports logging. So in this case, I don't use a log file. I just log to standard error. And yeah, the usual stuff. So log severity, log verbosity. And I think this is out. This is, that doesn't exist anymore anyway. So like this. Okay. So now I have that. So once I have this config, I can use this Atlas, this with config providers. So with config providers, and that takes the config, which I just read from file. Excuse me. excuse me. And now it takes a lock namespace, but lock namespace implements is an instance of isString. So we can just ignore that, or we can call it whatever, gift. So we can just specify that as a string. And now it takes a continuation, so given providers what to do. So providers. Right. Okay. And now what can we do once we have these providers? So there's, let me just, for the time being, just do undefined, whether until now everything is fine. So I must use overloaded strings. So this is something we haven't talked about. That's type level Haskell, but I think you can just, I mean, just think of it like a label. So that just says we want to use Plutus version 2. I needed it here as well. Okay, so far so good. So that seems to be correct. Right, so now what can I do once I have these providers? So there is something called run. If I import Genius Yield TX Builder. So there's this function that, I mean, ignore this for a second. So if we have a skeleton, a transaction skeleton, then that will create an actual transaction body. And we do have a skeleton. That was this function here that I created. Okay, and what is this stuff? So most importantly, we need the providers. This is my own addresses. This is the change address. And here I can optionally specify collateral. So we also need my own address somehow. And there is Genius Yield address, but if it is user facing, it's more convenient to use this because that's this batch 32 format that is normally used for humans to exchange addresses. So, okay. And there is a conversion function to convert that into an actual address. Address from batch 32. Address. Okay. So now I can use this function. So tx body. So run here tx monad node. Okay, what all do I need? So I need the providers. So that's basic, as I said, that's what I read from the configuration more or less, and that gives me the information how to talk to the blockchain, be it via Blockforce, via Maestro, or local node. Sorry. Now my own addresses. So I just use the one I specified here. I also use that as change address. Now the collateral, I think I don't need to specify that explicitly. Okay, now I need the skeleton. So let's look that up first. Actually, I can do that. No, sorry. No, I mean, I don't have to look it up first because I have that here. So that's just make gift with the value. Make gift with V. Okay, so this should be fine. I hope. No, it's not. Let's see. Okay, I have, oh, and the network ID. I forgot the network ID, but that's contained in the config. So I can look that up actually. So config network ID config, and I can use it here. Okay, so now this seems to be okay. Right, so now now that I have the body, I can sign it. So there is sign transaction body, tx body. So let's look up what that does. Sign tx body. So it takes the body and a list of keys. So I also need to look up my keys, which tells me that this was like not ideal. So instead of giving the address, I should give another file path for the where my secret key is, skey file. And now I can, there is something called read payment signing key from a file. So that's provided by Atlas. And now given this signing key, I can actually compute the public key from it. So v key slash payment verification key. So that takes a signing key and gives me a verification key. And given that one, I always forget what it's called. I think it's address from pub key hash, right? So first I need the pub key hash. So now I have the pub key. So the pub key hash is pub key, no, it's payment. Always forget as well. That's, yeah, I think it's this one. Yeah, it takes a verification key and gives me the hash of that. And now given this, I can, so I don't have to call it address prime anymore. I can just call it address. So that was address from pub key hash, pub key hash. Why is everything? Sorry. That takes the network as well. Address from pub key hash takes a network ID, but I have the network ID. Should change the order maybe. Okay. Right, and now I can use this. Okay, and now to sign, I must give a list of signing keys, but I have my signing key now. And this is now the sign transaction. Or actually, that's a pure function, I think. Okay, so far so good. And now finally there is submit somewhere. Yeah, submit tx. Given providers. Oh no, sorry. Yeah, and what is by submit tx? So given a transaction, it submits it and returns the transaction ID. So now I can just do by submit transaction providers tx. And that will return a transaction ID. Okay, so that would be what we did earlier with the Cardano CLI. You would do using Haskell and Atlas. And now, of course, the proof is in the pudding. So let's hope this works. So first I need the config file. I'm now not sure whether I'm in the right folder, but let's try it. So I'm do make gift IO. So I have config. It seems not. Okay. And now I need the file where the secret key is. So that was key something, but this is also, yeah. Yeah, okay. And I must specify the value. And if I want loveless, then I can use a function called or value singleton. Value singleton. And I always forget which order, so you must specify what currency and the amount. But I forgot in which order. So if you want loveless, it's GY loveless, and so might be wrong that I have to. And if we want to do 100 again, okay, that seemed to be the right way round. Okay, now we get some deep, our logging output, and we do get the transaction ID. So hopefully, let's see. And of course, I hope when we try to collect, we don't run into the same problem again as before. Let me just copy this. Okay, it's not yet in the Explorer, but it looked good. I mean, I didn't get an error, so hopefully that did transmit it. It normally takes a couple of seconds until it ends up on the blockchain, and then also a couple of seconds until it's in the Explorer. Okay. Normally, when I start getting nervous, then suddenly it works, yes. Okay, so that looks as before. I mean, I have no idea whether it's now the same script or, I mean, should be the same, exactly the same, but I mean, that looks all identical. So I hope we won't get the same problem again when we try to spend it. I should just make sure that that's the only Explorer I have open, that I don't get confused with the old one. Okay, right. And now for the collection part. So basically we need something like this. We must construct a transaction abstractly that collects, and then we must like do it for real with providers and so on. So let's do something like this. Collect gift. We think about parameters in a second. Let me just do it like this. So how do we specify which gift to collect? I mean, there's options. We could, for example, try to find all the gifts and collect all of them. Or we could specify UTXO specifically and only collect that one. So I think that's maybe the easiest. So let me do that now. GY, and that's called TX out ref, a reference to a TX out. Let's call it, I don't know, ref, or we could call it, yeah, let's call it ref. Okay, so now what I want to do is, in this case, all I care about that it must have a specific input, namely this gift. There's a type, as you won't surprise you, GYTX in. So let's see what all we need to specify for that. So first we need the reference that we already have. GYTX in, TX out ref. The reference from where we want to collect. And now we need this GYTX in witness. Sorry, and that's of type GYTX in witness. So let's see what that means. GYTX in witness. We make this bigger. So that can either be, like in the case of a public key address, it would be a secret key. or a script witness. In our case, it's a script witness. And in that case, we must provide the script. We must provide the datum and the redeemer. And then there again. Right. Okay. So we need this. And first we need the script, the datum, and the redeemer. I mean, we can define them before. So script. So there's something, I think it's called validator to script. So that's the script. The datum. So we can use what we used before. Datum from Plutus data unit, and redeemer can actually, so what's that? Okay, and I think there's also something redeemer from Plutus data, I hope. Yeah. Yeah. So we can do redeemer from Plutus data unit. I mean, it doesn't matter. We could also say 42 or something. Now we should be able to G by TX in, was it not witness, but I forgot again. G by TX in witness script, but it's called, the field is called witness. Was it called witness? Yeah. G by TX in witness script, and now the script and the datum and the redeemer. And why is it complaining? Because it's called gift validator. Why is it still complaining? In script. Okay, fine. So G by in script. So there are two ways. So I can give it. So I didn't need this here. Sorry. There are two ways we can explicitly give the script, and there's also something called reference scripts, but we can talk about that later. So I want to use this first version, G by in script, and then I can just give the validator. So it's G by in script gift validator. Right. So it's looking good. And now in principle, I mean, this is now a lot of code duplication, but in principle, I do more or less this exactly the same that I did here. Of course, in real code, you wouldn't duplicate this code like this, but so we don't need the value this time. Instead, we have this TX out ref where we want to collect from. But this we can all leave as is. Now instead we use collect gift here. Ref. Okay, looking good. So now we can hopefully this time collect it, but it might be that we run into exactly the same problem, in which case something would be wrong with Atlas. Okay, so now I must specify this TX out ref, and that has a string instance, so I should be able to just grab the transaction ID here and say #0. No. Oh,
You
must
have to
reload.
update the repo.
But now, I must set -x overloaded strings here as well. So let's see whether I get the same error. I do get the same error. Maybe not. The same problem as before, I think. The TX error auto balance. Plutus core language not available error. Never seen that before. But I probably also
Might be because of the protocol version, and now we changed to 8, and I'm not sure that maybe Genius Shield still serializes for 135, the previous one.
but I mean I'm trying. I mean I have just now used Atlas in exactly the same version on the just this morning I used it to construct transactions.
Right.
So it could be that Maestro is the problem. Let me try using Blockfrost. Maybe that could be an issue. That they still use a different version.
Maybe, yeah.
So I'm not sure whether it can be that.
Can you use your local node?
I'm sorry?
Can you use
No,
your
no, I can't because I mean, in principle I don't need to look up datums, but I don't have an index or anything.
All right.
And I think I would need that, even though I don't really need it in this example. But this is so weird. Codec error, Plutus core language not available. Hmm. Or something with the on-chain is wrong. But I thought I used. I mean, it could also be that the Plutus I'm creating is somehow wrong. That the Plutus version is not compatible or something. It's all very annoying. I'm not sure. I mean, I could try another provider, but I'm not sure that's very. Somehow I don't think it can be the provider, right? I mean, where does this come from? Codec error.
Yeah.
Oh,
Yeah,
but here it says 110, and here it says something about. I don't know, that's the same. But here it says. Well, there's also something. I mean, in the earlier in the. I mean, I didn't specify Babbage era. I think. Maybe is it. I think in earlier versions. Let me just try this one more time. Is it? Let me just go back to like before the break and. Oh, that's wrong. What's it called? Babbage, yeah, but maybe that must be right at the top. Oh, yeah. No, it doesn't, but I forgot this. Oh. Okay. That's because I restarted. So the environment variables are not set anymore. I see. And I think it's also not running the node right now. because I restarted. Okay, so now the node should be running again. And what else did I need this? What was it called for the testnet magic?
Testnet magic, two, two for
No, one.
one for pre-prod.
Yes, but what was the environment variable called?
All right.
Cardano network ID or something. But I forgot. Not sure.
See.
It wasn't called that. But I can, of course, also just specify the network magic explicitly here. Or testnet magic.
Testnet.
Uh-huh. If this now works, I will be highly upset.
Okay.
Oh,
Okay.
yeah.
Yeah.
Okay.
That's good.
Because I created a second gift, so now I don't have those anymore. So I must. What was my? Okay, and now this. Let me use the. We use the Explorer quickly. So I can use the change output from the last thing I did. And I used Atlas. So this one. So the second one. So one, index one of this transaction ID. So this is this one here. And the collateral. Probably it won't work, but who knows?
Same error.
Okay, same error. Okay. Right. Okay. Yeah. But okay, fine. But now I want to know why this thing, I get this weird error that I've never seen before. Plutus core language not available error. So it seems to be some protocol version issue, but I've never had that before. As I said, I've used this exact same version of Atlas just like 2 hours ago or something else, and it worked perfectly fine to create transaction that interacted with script inputs. I mean, I didn't use on-chain code. I mean, I used an existing script. So the only thing I can think of is that somehow my on-chain code maybe uses like a different version or something. But I mean, I don't even know how to specify this. I mean, with this compiled code. I mean, I don't know whether that. I mean, I should assume that that creates Plutus version 2, right? Maybe it's Plutus version 1, I don't know. But I don't think so.
Hmm. Yeah, no, I mean it was version 2 with the Plutus Pioneer, so and we didn't have to
Yes.
specify, so I think that's
And also this, I mean, right to file, I mean, we had the, I mean, this, it does say Plutus script version 2.
yep. The serialized function might be suspicious one because
Yes, yes, but now I'm not using it. I mean, now I'm using Atlas. Of course, there could be an issue. I mean, one could also check whether it's actually the same address. I mean, I now had, I mean, I made 2 gifts, right? If I go back to this address, that's my address. I mean, here, this was the last one that I did with Atlas. So that went to this address. And that's 2 different addresses. That's already like worrying. I mean, that should be the same, right? I mean, it's the same validator.
yes.
So why is it 2 different addresses? So one of the 2 is obviously wrong, but then I don't understand. I mean, so that could mean that the serialization, I mean, that this first one I did with the kernel that there the serialize was somehow did the wrong thing. But I mean, one of the 2 should be right.
Would it be possible that we had the wrong magic when creating the address of the keys? The
I
wrong,
think not. I mean, I did specify pre-prod in the config file, right? And it is 1 for pre-prod. I'm sure it's 1 for pre-prod and 2 for preview.
yes, but
And I also, sorry, yeah.
when we created the keys, we didn't specify because you had
No, for keys, you don't specify the network, only for the address. I mean, the keys are independent of the network. But then if you generate an address from keys, then it depends on
right.
on the network.
And at that point, we didn't have to specify the first time because you had the environment variable.
Yes. But it's also yeah, it's very strange that I get like different addresses. So something is fishy, and then I don't understand why I can't spend from the address now.
Yeah, even if the first one was wrong, this one should work, right?
Right. And this error is so weird. I mean, with wrong language version. I mean, is anyone of you aware, was there a recent like change in protocol? Was there a hard fork now? But
There was a change. I'm not sure if it was a hard fork, so not a protocol change. But when we changed the first time to 8, we added one extra parameter that when removed in 8.1. So I'm not sure if that might affect in some way, but I'm not sure if that was a hard fork or not.
I think we should have like another short break. Maybe I can think about it, like until 35 maybe, and then hopefully somehow we can figure it out.
We can ask the
Okay.
team as well.
Okay.
Okay, thank you. Fortunately, I have no idea. I did try it with another provider with Blockfrost in the meantime, but that gives me the same error, so it's not that. So I honestly don't know what's wrong. Does anybody have an idea?
Lars, sorry, I thought it was unmuted, but so I spoke to myself for like 30 seconds. No, I sent you a message that someone
Okay.
else had the same problem a while ago, and that
Okay.
was due to a serialization error.
Uh-huh.
So yeah, I think that's indeed like the error we're having. There's some issue with the we're serialization wrong. Not sure if we have the wrong version of Plutus or because something else is wrong. But not sure. I mean, we have to troubleshoot it, but at least we know the root cause.
Yes. It's just very strange. Let me just read your message. Okay. Just quickly. Oh yeah, this too much space thing, I see. It's just weird because I mean, because as I said, we're using this. I mean, it must be a recent change then, because Atlas, at least the off-chain part of, I mean, obviously the problem is somehow, yeah, some serialization error, but probably in both cases.
Lars, could you share your
Yes.
screen, please? Yeah.
Yeah, sure.
Someone in the chat asked about that.
Oh, right. But there was nothing really to see on my screen right now. I can share. Hang on. Share now. Great. Now I shared my key, but it doesn't matter. It's a free one anyway. Um. Yeah, so something, yeah, probably something is wrong with either creating the, I mean, serializing the script. Maybe something is wrong with my Cabal project file that I'm using. I mean, it could be that I'm using the wrong Plutus version for whatever reason.
Yes, I think this is the one of the risks for the first error, the seaboard deserialized error.
Yes. I could try just.
Because we compiled with the same version, right? We compiled the scripts with the same version when we use.
Yes.
Yeah, okay.
I mean, I used the same on-chain code for both, but of course I got different addresses, which is already strange. But maybe the Plutus version is wrong, but it is weird because, as I said, I'm using like the newest Atlas version actually. So the on-chain version should be right, but there must be some version conflict, probably between on-chain and off-chain code or something, that the code I'm creating is not the one that I'm trying to consume. It's a bit difficult to figure that out now. Trying to think what one can do, but because there's no proper way to, I mean, you can't compile a Pluto script. I mean, of course, I could use the old one from a couple of months ago. But even, yeah, even if that works, it's dissatisfying because then, I mean, one should use the newest version, of course. So not really sure what to do now to get that to work.
I'm not sure about right now, but between today and tomorrow, before the next lecture, we can like create this tight
Yes,
development environment that has everything inside Docker.
yes. I mean, this one does have everything inside, but it's probably the wrong stuff somehow. I don't know. It's weird. And right. And I mean, we do get two different errors. I mean, the one was this too much space, and the other one was this one here we get with Atlas somehow. This weird Plutus core language not available error, which is also related to serialization, it seems. Somehow it looks as if I mean, probably the on-chain code, the validator I'm defining here in this GIF thing, probably that somehow is wrong. Maybe this uses maybe the Plutus TX version is wrong or something. I mean, 1600, not sure whether that's, no idea whether that's right. I mean, I can try to Plutus TX. I don't know. Nope. Did I say 1.6? No. Yes. I mean, if this is any indication, then 1.6 sounds horribly outdated.
Yeah, we're in 14 now.
Right. Maybe that's it then.
1.6 is from May, so maybe somehow you have the wrong. I don't know how, but
Yes, I mean, I did basically copy it sort of from Genius Yield, but from the off-chain code of Genius Yield. And for the on-chain code, we have like a different, I mean, we have like two different Cabal projects, one for on-chain, one for off-chain. So maybe the off-chain reference is an outdated version of Plutus TX, and that doesn't matter because our on-chain is up to date. Something like that, maybe. Yeah, but I'm pretty sure it's something like that then. So probably the Plutus TX version is just too old. But I also don't know how to quickly fix that. Because if I change that in the Cabal project file now, then probably nothing else will compile. I mean, that's always the difficult part to get it work together. I can just, I mean, I thought I used, I mean, my Cabal project file actually, I mean, this is sort of here from somewhere from, I mean, this is from Atlas Cabal project. Oh yeah, here, okay, fine. This, I mean, I don't know whether, I can't imagine that. So, I mean, I could try to change that to 14, of course. But who knows what happens then. Is it, I mean, I can try that. But I'm pretty sure that won't work.
Yeah, 1.6 was before we changed the protocol to 8, to the 8 version node. So I'm guessing that's the issue.
Yes, yes. So I think then I would need a newer version of the chap.
Right, or another node.
Yes.
But maybe we,
yeah.
sorry, maybe we can troubleshoot this offline.
Yeah, yes, of course. Just one thing. I mean, it's a bit confusing because even if you use an old version, I mean, if I consistently use the old version, don't understand why that doesn't work. I mean, then the node could I mean, maybe the node is too new or something then. The node can't handle this old version. But as I said, I mean, yeah, it's strange. But yeah, let's troubleshoot that offline. So this is a bit, yeah, I'm sorry about that nothing worked today. So it probably has to do with incompatible versions here. But I'm also not sure. I mean, we could use the version from the Plutus Pioneer program. What was it, in May or so that we ran that? Or April, I don't. But of course, that's also bad because I mean, that is consistent, of course, but I mean, it uses an old node, which I think isn't compatible with the newest one anymore. So we need to upgrade that somehow anyway. Okay, yeah, let's troubleshoot that off chain. Sorry about that. But I mean, of course, what I explained is still all valid. It would just have been, of course, much more satisfying if we could actually demonstrate it that it works on the blockchain. But I mean, the code and everything is still fine. So hopefully I mean, in particular this and also the chain part. So it's just a version problem, I think. So hopefully if we figure that out until Thursday and then Thursday quick in the beginning, we can show that it works. And I'm sorry about that. But nevertheless, are there any questions?
Not so far.
Okay, yeah, then let's all forget about this lecture and then hopefully on Thursday I mean until Thursday we can figure it out somehow.
Yep.
To get it work. Okay, then thank you very much and talk to you on Thursday then.
Bye everyone.
Thank you. Bye.
Thank you. Bye.